All right, I guess let's go ahead and get started. Hello, everybody, and thank you for joining us here for a presentation on Rhino.Inside.Revit. My name is Luis Fraguada. I'm a developer and third-party developer supporter at McNeel Europe in Barcelona, Spain. And it's great to be invited to share a little bit of the work that we're doing for this Tools in Architecture seminar. I think you've had already some really interesting presentations, including one from my colleague, Frances Saya from Asuni, showing you about Visual Arc. Since Frances is here in Barcelona, we often correspond and collaborate together. So we're going to go through a little bit about the background of McNeel, background to Rhino, and mostly focusing on what is this project that we call Rhino.Inside.Revit. Okay, so just for some of you that might not know about McNeel itself, let's just go quickly through here. We are a company that has our headquarters in Seattle with regional offices in Barcelona, Miami, Seoul, Taipei, Tokyo, Kuala Lumpur, and Shanghai. Approximately 100 employees, 25 of those here in Barcelona, and we have a vast reseller and training network. So we have developer support in all of our locations, although now in the situation that we're in, we do a lot of our support obviously online and through these kinds of conferences. So last we checked, and these are very rough numbers, probably have actually more than 500,000 users by now, but we're very active in schools and universities, and we have a very large community of third-party developers that actually contribute quite a lot to the development of our products, specifically Rhino. So Rhino itself is a surface modeling application. It has access to import and export a ton of formats. Rhino itself started as a NURBS 3D modeler, so it excels at creating very accurate freeform geometry. And as Rhino has evolved, of course, it's added support for other kinds of types of geometric objects, such as meshes, sub-D, etc. Another important thing that we have a very strong third-party ecosystem, over 1,000 add-ons and plugins that you can, let's say, put inside of Rhino to enhance its capabilities. Rhino started being developed in 1993, and we've just recently, in December, released Rhino 7, both for Windows and for Mac. Some of the features in Rhino 7 that I'd just like to highlight before we move on to the main topic, which is Rhino.Inside.Revit, is that we've added quad remeshing. So you can create quad dominant meshes from surface, polysurfaces, meshes, and sub-D objects, which is it's a kind of an important aspect for us in a few respects. Number one, it really enhances the sort of reverse engineering workflow from a point cloud or a mesh that's, for example, brought in from a 3D scan to a nice quad mesh topological layout for starting to do other operations on top of. For Rhino 7, we've also added subdivision modeling. It's a new object and a new technology. It's all, let's say, high precision spline surfaces, and all of the sub-D object itself can be converted back and forth between NURBS and meshes, etc. So there's all sorts of, and this is very new for us in Rhino 7, but we've already had some really interesting results from our user community. Rhino, let's say Rhino is where it is today, also due to its third-party developers, and third-party developers are attracted to Rhino because we have a very rich ecosystem of development tools. This includes all sorts of open source projects, but importantly, this is a royalty-free software development kit in various languages. We offer you free developer support. We have dev days and hackathons, and we also have different platforms where you can actually distribute your developments. For example, we have Food for Rhino, where we can developers have a page there with their different projects, so that people can find out what it is that they're developing. We also have Grasshopper 3D, which is a visual programming environment. It's tightly integrated with Rhino, and it came out during the Rhino 4 release cycle, and now it's pretty mature. And there's been a few updates to that to Grasshopper for Rhino 7, but it's still, let's say, the same Grasshopper that our users have really enjoyed for the past several years. And of course, there's also SDKs for this. There's a rich ecosystem of add-ons already on the market. Most of these are free. That again adds functionality to what we deliver with our, let's say, quote unquote vanilla Grasshopper. And one of the things that we've seen in the last few years is, of course, more third-party applications integrating with Rhino. So this includes, for example, the ArchiCAD live connection to Grasshopper by Graphisoft, and other such projects such as the connection with Tekla or Sophistic. We have things like VisualArc, which is a Rhino plugin which adds bin capabilities to Rhino, and other projects that allow for data exchange, such as Speckle, which where you can, let's say, send data from Rhino or Grasshopper to Revit or to Unity or to Blender, etc. So there's a lot of really interesting applications on the market now. Again, most of these are, I say market, but most of these are applications that you don't necessarily need to pay for beyond the license to the programs. Rhino itself is used in many different industries. So if you're coming at this, if you're coming at and learning about Rhino from an AEC perspective, you're going to realize that Rhino is general purpose, and it's used in a lot of different industries, from shipping to jewelry to fashion to apparel to automotive to artistic endeavors, etc. I mean, Rhino itself, the core of Rhino is a general purpose freeform geometry modeler, but this eventually goes into all sorts of different industries, either through users that are really keen on Rhino in those industries, or developers that develop specific plugins to add certain functionalities that users from those industries would expect. Of course, since the beginning, Rhino is kind of pushed itself, pushed as an accurate platform for fabrication, so that the geometry that you're developing through NURBS or through our other object types is able to be produced. So that's also something to keep in mind when you're considering Rhino. Just highlight a couple, one of the projects here near and dear to us here in Barcelona is the Sagrada Familia. And for us, the fact that Rhino and Grasshopper are used in the development of this project still today is pretty incredible. The technical office of the Sagrada Familia started to use Rhino probably around Rhino 4, Rhino 3 or Rhino 4 to develop geometry using NURBS to eventually create the geometry for the fabrication of different elements, including this rose window here. But as time went on, and things like Grasshopper became more available, they started using Grasshopper to develop other tools. For example, here, some of the scaffolding used to create some of the, let's say, these mouths to the towers. So now they use a host of tools, but it's great to know that Rhino and Grasshopper are included in some of these tools. Modelical, which is an office, a BIM consultancy in Madrid, recently did a 3D scan of, let's say, the existing elements of the Sagrada Familia in order to have some documentation and to do a little bit of analysis on everything. So they were able to do 3D scanning and 3D modeling of the whole project in Rhino to serve as a guiding document for the rest of the development. And we're probably about 5 or so years away from the completion of the project, so we're really excited to see how this continues to evolve. One of the important parts of this work by Modelical is a scan of the nativity facade, which is incredibly detailed if you've ever seen it up close, and there was never any document that ever, let's say, represented this entirety of the facade until they carried out this work. So let's move on to what it is we're actually here discussing, which is Rhino Inside technology, and specifically Rhino Inside Revit. So before we get to talking about Rhino Inside Revit, we have to discuss in general Rhino Inside. And all of these things become much more relevant with our recent release of Rhino 7, because all of the work that we were doing towards this project was in the Rhino 7 WIP, and now that's been released. So what is Rhino Inside? Well, this is an open source project which allows Rhino and Grasshopper to run inside other 64-bit Windows applications such as Revit, AutoCAD, etc. What this means practically is from these other applications, you can start Rhino or Grasshopper either as a way to model in Rhino and Grasshopper, or you could just use Rhino and Grasshopper in the background as ways to calculate certain things that only Rhino and Grasshopper could potentially be doing. You can use all of our host APIs, Rhino Common, and the Grasshopper SDK to develop specific functionality. And you can eventually tie let's say the SDKs of both the host application with the SDK of Rhino and Grasshopper. So you can create eventually native objects in that host application. At the moment, we have samples for AutoCAD and Unreal and Unity and these kinds of things. But Rhino.Inside.Revit was one that we thought was important enough to really spend some time on and get some developers to look at in a much more focused manner. So that's what we're going to be looking at for the rest of the presentation. So Rhino.Inside.Revit is that. It's essentially being able to call into Rhino, open up Rhino as you would normally open it up, open up Grasshopper like that, or any combination of the things. So you could actually never even see Rhino or Grasshopper, but have it be calculating in the background certain geometric things. So we add over 300 Revit-aware components that Grasshopper can use to query, modify, and analyze native Revit elements. And so what this practically means, if you're a developer, it means that the Autodesk Revit API can talk directly with the Rhino Common API and interchange data. So here we're moving beyond files. We're moving beyond that. So we're not saving out, exporting a file from Rhino and bringing it into Revit. That's no longer the case. We're in the memory space translating Rhino objects to native Revit elements, or from native Revit elements directly to Rhino objects. There's no files involved here, and I think that's that's something that we should get used to. I think going forward, because these kinds of things I think relieve a lot of the pain points in interoperability between the applications. So there's all sorts of stuff, and I'll eventually show you the website where all of this information is hosted. But so you can create Revit elements and instances, you can change parameters in objects, you can create types and families, documentation, linking, different kinds of walls, curtain systems, materials, your own custom families, etc. So a lot of the functionality that you're used to being able to actually work with in Revit, you can actually automate that from Grasshopper itself. So practically, it means that we have, let's say, a Revit set of components in Grasshopper, and we can, combine that with the regular Grasshopper elements to create and automate the creation of objects within Revit itself. A couple of things that I want to highlight before we go on is that Revit geometry and Rhino geometry are for different purposes, right? I mean, Rhino geometry is Rhino's a general purpose modeler that serves a lot of different industries. So what might constitute a correct object, or an object that's built correctly, might be something that's completely built incorrectly for another industry. An example of this would be something like non-manifold meshes, or let's say a mesh that has that shares an edge with 3 different faces. Something like this in most industries where you need to fabricate something, it would be incorrect, because it would leave an ambiguity of what's like the inside or the outside of an object. But for industries such as geospatial modeling, where you need to model model and simulate different layers of, for example, strata of the Earth's mantle, you might want non-manifold geometry. And I'm just showing this picture here because this is something that came up on our discourse. A user was saying, that certain objects weren't coming in, and in recent releases of Rhino.Inside.Revit, the developers have added certain checks to make sure that only the geometry that Revit eventually will accept actually passes through. And this is a situation where the mesh for this robotic arm had some issues, and the components in Rhino.Inside.Revit and Grasshopper told the user, hey, there's some issues with this geometry. You might want to check it before you actually let it go through to Revit. So these are the kinds of things that are being added more recently into the Rhino.Inside.Revit projects to kind of match the expectations of Revit users and Revit itself. So as we learn more about the kind of geometry that Revit accepts and needs, we also add that kind of knowledge into the Rhino.Inside.Revit components. So that only the geometry that Revit will eventually expect can eventually get over there, and so you don't end up with bad objects or objects that Revit doesn't know how to read. So I'm going to do now a series of demonstrations, and I put here this kind of warning symbol to just ensure that these are demonstrations. I'm going to be switching back and forth between Rhino and Revit and all of these things. And well, as demos go, there's always a potential for things to go not as expected. In any case, let me just start off by going over to Revit. Okay, and I'm going to show you where you would see this. So the Rhino.Inside.Revit project is actually an executable that you would download and you would install. And then when you open up Revit itself, you're going to see this Rhino Inside tab over here, right? By default, you're going to get this initial component that allows you to start Rhino.Inside.Revit. This will eventually start Rhino and allow you to start working with Rhino.Inside.Revit. Some of the things that have been added recently to the interface is just a little bit more information about, the guides, how to get to the forums, some other options, etc. Some links to some really useful references here. So you have a little bit more information related to the project. But I think one of the important things here to maybe take a look at is that you can get updated on different kind of cycles of releases of Rhino.Inside.Revit. So if you are somebody who wants to make sure that whatever you're installing is relatively bug-free and has been tested, you're going to want to be on the public release, let's say, quote-unquote, official channel. But if you're somebody that's more on the bleeding edge of things and you want to make sure that you get all of the latest updates, you can also subscribe to the Daily Builds channel, and you'll be notified when those releases will eventually be coming in daily. Some other information, some other options here that are interesting. If you're using Rhino.Inside.Revit a lot, instead of having to go and click on the button to start it, you might want to start it when you start up Revit, and you might compact a few other things. So there's a few nice things that Eshan and Kike, the two principal developers of Rhino.Inside.Revit for us here at McNeel, have started to add to just kind of round out the project and make this project a little bit more meet the expectations of Revit users. Another important thing here is that you can eventually add your own custom scripts and Grasshopper definitions. You can add your own user script locations here. I don't have any installed at the moment, but eventually these will show up on the ribbon when you start up Rhino and when you start up Revit. So I am, let's say, subscribed to the daily builds because I also want to see what things are being updated. I think I just I updated yesterday, or I updated to yesterday's, but it's telling me that I have already a new release available. But I'm not going to go ahead and install that at the moment. But I can always see when there's a new release available because I have this little dot over here. So when we actually start up Rhino.Inside.Revit, we're going to get two other buttons here. We're going to get a button for Rhino, and this has a few different options, and that's, eventually switch over to the Rhino window, import a Rhino file directly in here, toggle the previews of some things, etc. There's a few other options there, but for now I'm just going to move on and show you what we have under the Grasshopper tab. So in Grasshopper, we are able to open up the Grasshopper editor. We can control the visualization of that if we want to actually see the preview of what's happening in Grasshopper in the Revit window itself. And anyways, these are certain things that you can access directly from Grasshopper, but it's also nice to have them here in the Revit interface. You also have a few other options to go directly to some of the specific folders that are relevant to Grasshopper itself. And you can also access the package manager, so you could actually even just install certain things directly from this interface. Okay, so if I click on this, I'm eventually going to get the Grasshopper window, and if I were to have clicked on Rhino, I'm eventually going to get the Rhino window itself. Okay, so this is a little bit of a let's say a tour around the interface elements that are added in Rhino.Inside.Revit. So the first thing I wanted to show you, the first demo that I wanted to do, is to actually go from Revit into Rhino. So show that workflow. And in the as this is, I've seen this develop in a few different steps, and I think I've also been in contact and working with a lot of different developers that have developed their own solutions for this. And I think what's interesting. Well, let me just show you and see and see what you think. So I'm gonna open up this very very particular project. You might know it. You might have seen this before, and it's the rack as we all know it. So what if I want to bring this project with all of its elements, all of its materials, everything into Rhino itself? What can I do? Well, what I'm going to do is I'm going to go into Rhino Inside. I'm going to open up Grasshopper. Let's see. It's got some units. Okay, adjust model to feed like Grasshopper. Well, let's cancel that out. Let's just continue on. So here, what I want to do is I'm going to look at what Grasshopper actually now offers you. So when you install Rhino inside Revit, you're going to get a couple of things. So first of all, you're going to get the Revit tab, and this includes a ton of different features, a ton of different components to actually be able to work and do all the things you expect to do within Revit. So you can create families, direct shapes, host all sorts of things inside of other objects, work with sites and topographies, etc. So, but what I'm actually going to do is I'm going to reference something directly from the Revit model. I'm going to bring here a params Revit primitives graphical element, just one component. All right. So I'm going to right click and I'm going to say set multiple graphical elements. So if you're used to working in Grasshopper, you know that this is normally used for that sort of workflow is normally used for referencing things within Rhino itself. But we can actually just reference everything here in this model from Revit. So I'm going to go ahead and select all of this. There we go. Okay, I've selected it. I'm going to say finish. Okay, and when I do that, I have it here directly in Grasshopper. And what that means is that I should be able to preview it in Rhino itself. So let me look at how this looks in Rhino. Okay, there we go. I have the preview object here in Rhino. And what I'm actually going to do, so right now it's just a preview, since that's what normally Grasshopper gives you. So what I'm going to do now is I'm going to actually add this as, here we go. I'm going to bake this directly into Rhino so that I actually have the model and I can do things with it as I would expect to do with it. So I have it here. I'm going to right click. Sorry, I'm going to select it here. I'm going to right click and I'm going to say bake. And I hope that you can see what's happening here on my screen. So I'm going bit by bit and it's looking at all the elements that I've referenced and it's adding a layer for every different kind of object. The site here takes a little bit longer, and since we're sharing, it might take a little bit longer. But as you can see, I have the model, and then in there I have floors, walls, roofs, topography, etc. So all of the categories that the family categories that we have in Revit are represented in Rhino as a layer. Something that I'll show you a little bit further on is that the objects. There we go. The objects themselves aren't just necessarily brought in as as regular Rhino objects, but if there's a family with multiple instances, we actually take advantage of Rhino's blocks and bring those in as blocks. So I'm going to turn this off and hide this way. And you can see I have tons of layers, all sorts of stuff here. Those layers might have some materials associated with them, etc. Let's go ahead and take a look at this in our rendered view, because I think it's worth noticing that when we actually look at this and want to use it for rendering, the materials have also come across so that things look, I think, pretty decent. If we're eventually able to shade this here, there we go. Okay, so all those materials came across. If it's glass, the glass has transparency, so all of those properties are there. And we have everything in the model. We have the entourage, the plants, the topography, all of these things are here carried along. And if you've ever tried to get models from Revit to Rhino, you know that just having such a one component solution is pretty cool. So I'm happy to show that and show that it's how relatively painless that was. Now, what I was mentioning before is that this could potentially be a really big model if we have different instances of stuff coming in. But what you actually should take a look at is that if the objects, of course, are part of a family, then you're going to get that in as a block. And so we're going to create blocks as we're bringing that in, and we're going to have all sorts of instances eventually added to the Rhino model. So it's a relatively, if we save this as a Rhino file, I think it's a 40 megabyte model or so with all of the different blocks. Okay. So of course I could save this as a Rhino model now and do whatever else I want. I just want to show you that this kind of workflow, of course, has legs, and we're developing this further. But for example, let's say that I wanted to continue on with this model, and I don't know, try to bring it into a browser. And I've already brought this in over to the 3JS. We develop also a 3JS Rhino 3DM loader. So I have here the same model that I just exported in 3JS. Now, I'm actually the developer of the Rhino 3DM loader for 3JS, and I see that I have a little bit of work to do left to properly support all of the materials or material types. Some stuff came through, as I can see. There's some things here, but I have to do a little bit more work on the materials. But all the geometry is there. So that was, from Revit to Rhino, and eventually opening it up here. All I did was file import and brought in the 3DM file. So if you are looking to do different rendering workflows, or workflows where you might be going to, I don't know, Unity or Unreal or some other, let's say, visualization engine, this could be an interesting workflow for you. All right, so let's go ahead and just start a new file here. And I want to discuss now going perhaps a different direction. So that was from Revit over to Rhino. And I'm going to clear stuff out here. And I'm going to eventually go ahead and close off what I have in Grasshopper. Again, that was one component to bring all that. I think that's pretty cool. Let me just go ahead and close these things and go back to Revit. So the second demonstration that I want to show is from Rhino to Revit and actually creating native Revit elements. Because, I mean, it would be one thing if we were able to just bring the geometry made in Rhino to Revit as, like a direct shape or something like that. But really what people want is to create native Revit elements. If I'm making floors, I don't want that floor to be some kind of mesh or something else. I want that floor to be a floor type that has its parameters, its material properties. I want that, all that work to be automated. So Rhino.Inside.Revit allows you to do that. So let me go ahead and open up a model in Rhino that I have already here. That's going to demonstrate a few different features related to creating native Revit geometry. So here I have a very rough model. Let's say this could be something like a conceptual model where I'm starting to already organize things. I might have some floor levels, etc. But I want to eventually start to bring some of this into Revit. Let me open up Grasshopper here, and I have a definition prepared where I demonstrate this. So it's over here. All right. So already, if I did this, you would already start to see some kind of preview inside of Revit itself. So just like we preview the geometry inside of Rhino, we also have a preview of what's happening in Grasshopper inside of Revit. And of course, I can control that by turning this off here or wire or etc. So similar way that I can control that inside of Grasshopper, I can control it inside of Revit here. Okay, but already I've already brought in some of these layers, some of these levels that I've created inside of Grasshopper. So let me see what I actually did there. So what I'm doing inside of Grasshopper, I'm using a plugin called Elephant to actually reference things from the Rhino model, from different layers. So I have a layer here somewhere called floor curves, probably this one here, which contains some curves related to the floors. Now, I've drawn this in Rhino. Of course, these could be generated with Grasshopper itself, but I'm referencing these, and I'm going to eventually create these levels. So that's the first thing I do. I create these add level by elevation. Okay, so the levels have a name, and if I look at here, so I have floor 1, floor 2, etc., and roof. So I'm first creating those levels, and if I go back to Revit, you see that those levels have actually been created from the Grasshopper definition. So that's there. That's a native Revit level, let's say. And if I go back to Grasshopper, so what I'm doing is I'm taking that curve, and I'm eventually getting the height of that curve. I use that height to create the level by elevation. I give that level a name, and that's what we see in the index. But eventually what I have is I want to create a floor. So I'm going to add floor by outline. My outlines are coming from Rhino. I referenced them in Grasshopper, and now this is disabled, but I want to eventually do that. So I'm going to enable that. And if I look at what I have now inside of Revit, I see that I have these floors created. Now, of course, I could create those as direct shapes, but actually this is, a floor. It has properties. It has parameters. It has different, it's hosted on a level. So there's all the properties that we'd expect to eventually create with Revit can transfer through. Okay, so that's and this is where I eventually set up what the type of floor it was. So I have here, let's say the model category, and eventually the type that's gonna be. So I can set all that up and eventually pass that over to Revit. Now I can also do something similar. Here I'll just show you, for example, how to do it if you have some columns. So this is the add column by curve component, and in the model I have some curves somewhere in here. I think that's these curves down here that I've actually sort of created inside of Rhino and then Grasshopper. I have some points, and I create some curves vertically. Okay, so I had those points there. Maybe those points were important for a foundation or something like that. But in this case, I'm just generating some points, and eventually, I'm generating some curves, and so I'm going to pass that to this add column by curve. So there's a couple of inputs there. There's the curve itself, in this case the line. There's the type, and eventually the level. Since I don't put any level, it's just going to, I think, go to the ground level by default. So I'm going to pass this in. It'll take a moment here, and eventually you see that it's telling me that there's some identical instances in the same place. This will result in double counting in schedules. Okay, fair enough. But actually, I don't like that. I don't like that Revit has complained that's the case. So what I can do, and you'll notice here that the component in Grasshopper is actually giving us the same warning. So this is something that's been really important to add to Rhino inside Revit, is that the warnings that we see in Revit actually manifest themselves as well inside of Grasshopper. So what I can actually do, I can lean on another plugin that actually ships with Grasshopper itself, which is the Kangaroo 2 set of tools by Daniel Piker. And here I know that there's a handy tool to filter out duplicate lines. And for whatever reason, here I have 45 lines, but I think there might be a duplicate here. So what I'm going to do is I'm going to pass it through here. I start with 45 lines and I end up with actually 18 lines. So somewhere along the way, I somehow duplicated the amount of lines. So I'm going to now pass just these 18 lines, and we'll notice that the errors that we were getting, or the warnings we were getting inside of Revit, actually go away, and we have our nice columns. This is, again, a native Revit column. It's got a type, it's got properties, and everything that we expect. It's hosted on the floor 0 because that's the base one, and everything that we expect with these elements as we're bringing them into Revit are there. And I have one more part to this example that I wanted to show you, which is actually this this part here, which is to create a curtain wall from within Grasshopper. And here we're going to lean on another set of tools, in this case, paneling tools by a McNeel developer, Raja Issa. And the suite of tools really facilitates the creation of different paneling organizations on surfaces and different kinds of geometry. So here we're actually subdividing a surface into different set of UNV domains, and eventually creating a panel. So what this is going to do is actually create is a workflow to create adaptive components from within Grasshopper and pass those into Revit. So I've created this subdivision of the surface. You can see here we have different lines. What I'm doing here is I'm randomizing a little bit the types. So I have here. So I'm taking some and I'm making some frame panel, and maybe another one, there's a different kind of panel. Maybe, hopefully this won't, this will do it as expected. Let's see what happens. It's disabled now, so it's not coming in. Let me just move the window so you can get a little bit of an idea of what's happening here. Let me get this into a good view. There we go. All right, so let me pass in these adaptive components. This is the add component adaptive. So I'm going to enable that. And hopefully what this means is that these pieces are going to be instantiated over in Revit itself. I hope. So I guess the main point of these last two is that we should be able to eventually do all sorts of things here. And there we go. Eventually it's added. And you can see the different types represented in slightly different colors. So I guess what I also wanted to mention is, beyond being able to create all of the native Revit geometry and types and families from within Grasshopper itself, you can also lean on the rich ecosystem of plugins and add-ons that already exist for Rhino and Grasshopper to do different elements here. So we used Kangaroo here to filter out duplicate lines up here before, somewhere over here. And we're using paneling tools to actually create this paneling, these adaptive components. And since we have two different types and we sort of randomized which types it were, we see that here we have this adaptive component with this kind of type, and then we have another one over here with a different type. So we can all do all that kind of stuff, which is kind of neat. And I have one more demonstration to show you, which is still going from Rhino to Revit, but also being able to create all of this with subcategory information embedded in the object itself. So let's see what that looks like. Let me go ahead. I'm going to close this out here. And I'm going to open up another model. And we'll see what this looks like in a moment here. All right, so this is kind of like a walkway. Perhaps this is something that would be created for a project by a custom by a fabricator or something. And we have here, let's say, the footings and the rest of the parts. All right, I'm going to, here in Revit, I'm just going to switch over to this template that I have for it. Okay. All right. So again, we have the parts of this model in different layers. Okay, according to the different aspects that we're interested in. I'm going to open up a definition that I've prepared that kind of demonstrates how to get even more detailed with the kind of subcategories for the objects. And this is, as you probably know, working in Revit is really powerful when you want to represent and do documentation and be able to really control the documentation per object type. So I'm going to let this open here. Now, none of these are none of the components here are disabled, so it's probably opening and passing data over to Revit as we speak. Let's see, what do we get? Do I have something in Revit? Here we go. There we are. All right. So it did everything at once. I opened it and passed all the geometry and objects over to Revit. Okay, it also has a preview. I'm actually going to turn the preview off here, and I'm going to turn the preview off over here. So let me just walk through for a moment what I have going on in Grasshopper. So I'm referencing some of the objects here in two different groupings. Okay, so I'm going to take the foundation and work with that separately, and then the rest of the objects, for example, the columns and the roof panels and the roof beams, etc. I'm going to treat them. I'm going to work with those all together. So I'm referencing the objects from layers. I'm eventually going to assign some subcategories, and I'm also going to assign some materials. Okay, so I can do all of that kind of stuff from within Grasshopper itself. Here is the create materials component, the component family, and eventually the new component family. So I'm creating new families, and eventually when I'm finished, I'm going to add the component itself. And here I'm referencing directly from the family templates. So the structural foundation family is going to be these canopy footings, and eventually from the site family templates, I'm going to just use the walkway category. So let me just go back now into Revit itself and see what I have here. So here is our walkway. All right. As I mentioned, and we have the footings themselves, these canopy footings, and two different things. And maybe because you might have one contractor that's going to work and put in the footings, and another contractor that's fabricating the walkway itself is going to put the walkway on those footings. So here, what I wanted to display is that, of course, you can have in the case of wanting to document this, of course we're going to have objects with different line types and attributes, but because we have these on different subcategories, we can go in and really control the display attributes of that. So for example, if I went into the visible graphics overrides, I could eventually go here to object styles and kind of go down to where, under the site family, which is where I've hosted a lot of these things. So if I have, I don't know, for example, canopy columns, or maybe the canopy beams, panel frame panels. Maybe if I take the beams, for example, I don't know, and I change the color because I really want to highlight them here, so I change them magenta. Let's see if we get, and you see that here, of course, we were able to just edit that, the display style of those beams, and it was really simple because we have them organized by subcategory. Just look at an elevation here. You see that, of course, that comes through in different representations. I mean, I guess another thing that you can notice here is that, the materials that were set in Grasshopper are also, coming through for the most part over here as well. So yeah, that's the idea, that you can really automate and control all of the stuff from within Rhino and Grasshopper itself. And gives you that, not just the ability to pass geometry back and forth, but also pass, object properties, parameters, create families, create objects, etc. Wow, so my demos have somehow worked without any incident yet. That's good. So those are 3 different just brief demonstrations that I wanted to show you, sort of highlighting maybe some of the more recent work that's been done in Rhino.Inside.Revit. And I just wanted to mention that, how does this actually all work? Well, actually, Rhino.Inside.Revit is an open source project. If you want to see what any of these components do, how the component itself creates the geometry or creates the objects and passes them to Revit, you can see what the developers are doing. We have two really good developers, Kike Garcia, who also helps to develop VisualArc, as well as Hassan Iran Najad, who you might know him from PyRevit. He's a developer of PyRevit itself. And we also have Scott Davidson, who has been working to really manage a lot of the documentation and the guides to all of this. So it's an open source project. It's free. You just need a license of Rhino, a license of Revit to make it work. I think you might have seen a presentation before by my colleague Frances Saya, and yeah, as I've kind of been showing, that if there's already a plugin or an add-on for Rhino or Grasshopper that exists in the ecosystems, you can also use these to work within all of this. So they also come along for the ride. You might have already seen this video. Some of the resources that of some of the things that I've shown you today can all be found on rhino3d.com/inside/Revit. There we have, of course, getting started with all of this, some different guides, and I think one of my favorite aspects is this Discover page, where you can see that it's not just us, that are excited about this, but there's a lot of other people that are doing things with it. For example, our colleagues at Proving Ground have a plugin called Conveyor, which does take advantage of some of the Rhino Inside technology if you do happen to have Rhino running inside of Revit at the time that you use it. So you should definitely check out what they're doing with Conveyor to see if that's something that can help you speed up the workflow of interoperating between the two softwares. But yeah, this is constantly updated, and people are, I think, as excited as we are to work with all of this. From my part, that's pretty much everything I wanted to cover today. You can get a hold of me at luis@mcneel.com, and if you want to check out all of these resources that I've been talking about, again, you can go to www.rhino3d.com/inside/Revit, and you'll get all of the stuff that I'm talking about. There's videos, there's all sorts of guides, there's component references, etc. and also a link to our discourse in case you want to connect with other Rhino Inside Revit users, or just our Rhino 3D community at large, which of course you'll find people that are working all sorts of industries outside of architecture, engineering, and construction. So from my side, thank you very much. I appreciate you listening today, and hopefully we can connect later on, and we can ask questions or show us what you're doing with this stuff. Thank you very much.